So we're going to look at this redox reaction here, and there could be some sort of anion, like a sulfate in solution. It could have been given to you as CuSO4 and then Al2SO4 here. And you would need to know that because it's aqueous, it's going to ionize, right? Anytime you see the word aqueous, you know it's going to break up into the ions. So both of those would. And we only care about the cations, the positive charges. So how do we first, let's say we didn't know if there was a reaction or not. How would we determine if there was indeed a reaction? What would we need to do? So in this case, we have the solid above the ion in the solution, copper, right? So it should be that way. Otherwise, if the metal is not above the ion, no reaction would take place. So what is the first step in the ion electron method? Half reactions, good. Okay, so when we do that, we're going to get a Al solid, and it's going to go into Al3 plus aqueous. And then the other one is going to be Cu2 plus aqueous, a little space, and then we're going to have a Cu solid. Now notice I wrote a little space right here. The reason I put the space is because this is going to undergo what process? Yeah, it's going to be for the electron, so what process is this? Is this going to be your reduction one, or is this going to be your oxidation one? It's going to be the oxidizing. Okay, so let's say it correctly. You're correct. It's the oxidizing agent, but it's undergoing reduction. Okay, the process is called reduction when you gain the electrons, but it is the oxidizing agent. Good girl. And we will eventually put the electrons here. And then here, up here, this is undergoing, as a result, what? Oxidation. Good girl. All right, so now at this point, what do? What do we have to balance? What's the first thing we balance? Okay, well, there's actually a few steps before the electrons. In this case, those steps don't apply. First, you should balance the elements that aren't hydrogen or oxygen. In this case, aluminum's balanced. There's one aluminum on the left, one on the right. Copper's balanced, one on each side. So then we would balance the oxygens by adding water. This is for an acidic solution, if they were asking, okay? And then balance H pluses. Or balance hydrogens by adding H pluses. Then you get to the electrons, okay, for the charge. Now in this case, you'll see that there is no oxygens, there is no hydrogens, right? So we go straight to the electrons. So when we go straight to the electrons, what's the charge on the left side here? Zero, right? What's the charge on the right side? 3 plus, she says. And then how many electrons do I need to add in order to get the same charge on both sides? Yes, ma'am. Okay. Now let's look at the bottom one. What's the charge on the left side? What's the charge on the right side? How many electrons do I need to add? On the left side, right? To make it neutral. Good. So now what do? Are we done? Okay. What do I do? Good. So how would I achieve that goal? Okay. And? Is that it? Good. So when I do that, I'm going to get 2Al, a solid, 2Al3 plus, aqueous, plus 6 electrons, and then 3Cu2 plus 6 electrons, 3Cus. Now what do? Well, if you add them, you get... Are we done? The answer is yes. We should now be charged both, or balanced both by charge and the number of atoms. And let's double check. We got 2 aluminums here, 2 aluminums there, 3 coppers here, 3 coppers there. The charge on the left is going to be 2 plus times 3, which is 6 plus. This is 2 times 3 plus, which is 6 plus. So we're good to go. All right? Do you understand?